So, good day everyone. This is ECE23, task number 8, Introduction to Digital Communication. This is yours truly, Mr. Arcabal. So, for today's discussion, we have performance task number 8, our objective and requirement. So, to demonstrate the principles of information theory by determining the entropy and sending a message by using Shannon's and Hartley equations. Requirement: create a tutorial or discussion video on how to compute for entropy using Shannon's entropy equation. Use your name as an individual reference. So we have here our example. So next, based only on the resulting letters or symbols, determine the following. So we have here A, B, and C. And make summary by comparing the results and draw your conclusion on which machine is better. So from the given example above, we have here our full name, combined, and arranged alphabetical. So we have here our scenario. Playing card guessing game using the letters above. You will assign to pick a card randomly and guess the card you've picked. Assuming you pick card letter Z but you still don't know the answer. So we have two scenarios. You will ask, is it A or B or C? So my answer is no. You will ask again, is it I or L? My answer is no. And is it R or T? My answer is Z. So your answer is Z. Given from above questions, you ask the 7 letters and my answer is no. So you will derive that the card you pick is letter Z. So at case number 2, we will ask, is it A or B? My answer is no. Is it C or I? My answer is no. And you will ask, is, is it L or R or T? So my answer is no. So you already asked the 7 letters. So you will already know that the card you've drawn is the letter Z. So discussion. So we have here our binary machine number 1. So for example, at case number 1, you will ask, is it A or B or Z? So if my answer is yes, it means it display as 1. So if my answer is no, it will display 0. So for example, you've asked again, is it A? So my answer is yes, 1. And if it is no, equals to 0. So let's compute the probabilities from given uh, binary machine from our graph. So solving our probabilities, we have this formula or equation, 2 raised to negative n, where our n is the number of bits from our given graph. So at probability A, 0.25, so it is derived from 2 raised to negative number of bits. So we have 2 number of bits. So 2 raised to negative 2, it is equals to 0.25. Also true for probability B at here. So we have here 3 number of bits, 1, 0, and 1. So 2 raised to negative 3, we have 0.125. So this probability is up to this probability Z. So the formula is 2 raised to negative n, where n is the number of bits. So for getting the number of bits, we have this path at our form given equation, given graph. So for example, at probability T, at this part, we have this number of bits, 0, 0, 1, 0. So we have here 0, 0, 1, 0. So it means we have number of bits is 4. So this is how you get our probabilities. So at this part, for example, probability R, so we have uh, 0, 0, 1, 1. So 2 raised to negative 4. So it is 0.0625. So it is true at all these probabilities. Same formula or procedure. So probability method. So solving for the entropy or H using the probability method. So we have here 1 times 0.25 times 2, where 0.25 is the probability, 1 is the how many times it occur in our graph, and 2 as the number of bits. So same, it is true also for 0.125 times 5 because it occur 5 times in our graph, and times 3 because we this have 3 number of bits. So same is true at 0.0625. It occurs two times and we have 4 bits. So simplifying our equation, we derive our entropy or eta at 2.875 using probability method. So using Hartley equation or Hartley function, we have this formula 0.25 at this probability, and 0.125 it occur 5 times log of 2 of 0.125. So simplifying this equation, it derives to same answer using Hartley equation 2.875. So next, binary machine number 2. So case number 2, same procedure. You ask, is it A or B? My answer is yes, will be 1. And my answer is no, it will be 0. So for example, you ask again, is if it is A. So we have two probabilities, A and B. So for example, you ask, answer is no, and you ask C or I. So you have this 1 if yes and 0 if it is no. So for example, you ask again, it is C. So 1 if it is true and 0 it is if it is no. So same up to our last part of this graph. So same process using computing the probabilities. We have the formula 2 raised to negative n, where n is number of bits. So at this probability A, we have at this point, we have 2 number of bits at our path. So 1, 1. So 2 raised to negative 2, we have 0.125 at probability letter L. This part, we have 0, 0, 1, 1. This is the number of bits, 0, 0, 1, 1. So 2 raised to negative 4, we have answer of 0.0625. So same, true at this probability letter R, we have this number of bits 0, 0, 1, 0, 1, 1. So 2 raised to negative 6, where 6 is the number, n is the number of bits, so 6. 2 raised to negative 6, it is equals to 0.015625. So same procedure using probability method, solving for entropy or eta. 2 times 0.25 times 2, we have 0.25 here. It occurs 2 times and 2 number of bits, same. 3 times 0.125, it occurs 3 times and we have 3 number of bits. So 1 times 0.0625 times 4, for 1, occur once and have 4 bits, same true. 0.015625 times 6, 6 digits and 6 number of bits, and it occurred 2 times. So we have simplifying our equation, we derive to this answer 2.5625, and using a Hartley equation or Hartley function, we have this formula. Same procedure at our binary machine number 1. We have also derived 2.5625. So in summarization, our machine number 1 has an entropy of 2.875, machine number 2, 2.5625, and our H max is 3. So for getting our H max, we have here our formula, log 2 of 8. For our n, also 0.958, we have also our formula, same as machine number 2. So we have here at machine number 1, we have highest entropy, less predictable, low probability, and most random. So at machine number 2, for summarization and comparing, machine number 2 has lowest entropy, more predictable, higher probability, and less random. So less information needed to be transmitted to get the desired outcome, and machine number 1 has more information needed to be transmitted to get the desired outcome. So in short, machine number 2 is better than machine number 1. So that's all for this video, and for how to compute an entropy or probability of using our binary machine. So that's all, and thank you.